Differential and integral operations 10. A force field is given by the relationship F is equal to 2x plus 2y parentheses ex hat plus 2y plus 2x parentheses ey hat. What is divergence and what is curl of F? Sketch the force field lines. This is a conservative field. What is its potential? And sketch the equipotentials. Okay, so let's remember divergence of F. What is divergence of F in part A? Divergence of F means we're taking the dot product of del xi ei hat with fj ej hat, which is nothing but Kronecker delta ij del fi del xi, which means divergence of F is del fx del x plus del fy del y. The last term is 0 because there is no z component. Okay, so we can calculate divergence of F. Divergence of F is del x of 2x plus 2y, which was the x component, and del y of 2x plus 2y, which was also the y component, or 2y plus 2x. Doesn't matter. And divergence of F becomes the partial derivative with respect to x for this part is 2. For the other part is also 2, so this is 4. So our answer to part A, divergence of F, is 4. Now part B asks me curl of F. Curl of F is calculated using this determinant ex hat del x 2x plus 2y, and then we have 2y plus 2x del y ey hat, and then we have ez hat del z, and this part is 0. So this is plus minus plus, doing it with respect to the first row. For ex hat, I have to cross out the first column and the first row. Del y 0. So I have del y 0 minus del z 2x plus 2y, which is also 0. And for the second term, minus ey hat term, this one, I have to cross out the first row, second column, del x 0, del x 0, minus del z 2x plus 2y, which is also 0. And for the last one, ez hat term, I cross out the first row and last column, del x 2y plus 2x, minus del y 2x plus 2y. All right, and the first two terms were already 0. For ez hat term, I obtained the partial derivative with respect to x is 2, and this is also 2. So it's easy hat 2 minus 2, which is 0. Therefore, my conclusion is that curl of f is 0. Now, if the curl is 0, that means it can be derived from a potential. So the force can be written as minus gradient of phi. This is part D. And that is minus del phi del x ex hat minus del phi del y ey hat, and that is 2x plus 2y ex hat plus 2y plus 2x ey hat. So I have two equations. I can use this first equation. The derivative with respect to x is to be, let's see, 2x plus 2y. So that means this is going to imply phi of xy is x squared plus 2xy plus f of y, or y squared plus 2xy plus g of x. Why? Because the partial derivative with respect to x has to be partial derivative with respect to x will give me 2x plus 2y, and the partial derivative with respect to y will give me 2y plus 2x. So that's the situation here. Here I'm looking at this as a conservative field, and because of the minus sign, obviously I need to include a minus over here. So this tells me that my scalar function phi should be phi of xy should be minus x plus y parentheses square. So it's minus the gradient will give me minus 2x, but the minus sign will be getting, we will get rid of 2 times x plus y, the derivative with respect to x and derivative with respect to y. So the scalar potential I'm looking for is minus x plus y square. Okay, so here I have x plus y parentheses square for part C and E. Instead of the minus sign here, I have used x plus y parentheses square just to demonstrate it. And if I take this gradient of this, instead of minus the gradient, I will have the force. So you can see here. So that's what I have envisioned. So instead of using f is equal to minus gradient f, here I have assumed f is equal to gradient of phi. Okay, for this demonstration. So with that, I obtain the counterplot of the potential, scalar potential, in between minus 5 and plus 5. And you can see the constant potential surfaces on this plot. And if I take the gradient x component and gradient y component, fx and fy, and I do a vector plot, then I can see that these arrows will show me the vector field, and the color indicates the magnitude. So you can see that when x and y are approaching 0, the force is approaching 0. And when they are becoming large, the force is becoming large. So the temperature map shows that it's getting closer and closer to red.